All right, it has hit 12 o'clock, so I will go ahead and get this train rolling. Thanks again, everyone, for joining us today for another exciting hour of Code Talk. Today, we'll be talking about the 2021 IECC for existing residential buildings. So today, we're focusing primarily on existing buildings and existing residential in specific. So today, your presenters are myself, Robert Schlorf, and my colleague, Sean Maurer. Our learning objectives for today. By the end of this presentation, you all will be able to navigate the layout of Chapter 5 of the IECC for residential buildings, define the scope and applicability of the Energy Code as it applies to existing residential buildings, explain the differences in code requirements for additions, alterations, repairs, and historic residential buildings, and lastly, apply real-world examples to better understand the requirements of Chapter 5 for residential buildings. Who we are CDEC, the Smart Energy Design Assistance Center. Our mission is simply to reduce the energy footprint of Illinois and beyond. What we do, CDEC is an applied research program here at the University of Illinois, housed in Champaign-Urbana. We assist buildings and communities in achieving energy efficiency, saving money, and becoming more sustainable. So we do that by helping facilities become more energy efficient. We educate, we research, and we advocate for a greener future for us all. CDEC is the Illinois Energy Conservation Code training provider. Today's webinar is brought to you by the Illinois EPA Office of Energy. CDEC collaborates with the Illinois EPA to provide code training and technical assistance for the Illinois Energy Conservation Code. CDEC is also a preferred education provider with the International Code Council, as well as this presentation is also approved for 1 credit from the American Institute of Architects. If you provided AIA or ICC member information when you registered for this presentation, we will submit credits on your behalf. If you did not provide that information, you can send it to us via email and we will take care of the credits for you. Otherwise, anyone else registered for this course will receive a credit via email after completion of the presentation. Our presentation will also be posted to our website after today and available for view anytime after that. Energy Code Assistance, as I said, we do training, but we also have a hotline for Energy Code Assistance. If you have any questions about the Energy Code, you can reach out to us at energycode@cdac.org, or you can call our 800 number there, 800-214-7954. We do often suggest people send an email rather than a call, just because it allows multiple people here in the office to get eyes on the question. We can pass it between ourselves, come up with the best possible answer, and give you a thorough written response to your question that may be a little bit more helpful than a phone call. But of course, the phone number is there, and you are more than welcome to call us for quick questions or anything else as well if you just want to have a phone call rather than an email. We also have online resources at our website, smartenergy.illinois.edu/energycode. On that site, you will find our past workshops and webinars, as well as the schedule for upcoming workshops and webinars. We also have on our website online on-demand training modules. These are self-paced modules that you can receive credit for as well. You just simply need to register on our website and then walk yourself through the training modules. We have quite a few up there, and we plan to add more in the future as well. Also on our website, you'll find some other resources, as well as smart energy tips and more information about the codes. So our CDEC Energy Code training series for this program year, our last presentation, Energy Code Basics, was finished last month. Today, we are talking about existing residential buildings. Our next presentation will be on residential stretch code coming up in November. So what's happening in October? We have our first in-person workshop for the year. So our first in-person workshop will be located in Springfield on October 24th. That presentation will be covering Energy Code Basics, simplifying code compliance, and Q&A review. So we're going to kind of walk you through how we handle code questions when we get them. And then we will have a second workshop located in a to be determined early in the spring. So the Illinois Energy Conservation Code, this is maybe why a lot of you have come today to see if you can get an update on this information. The current information that we have is that the 2021 Illinois Energy Conservation Code, or the 2021 IECC with Illinois amendments, is expected to become effective as early as November 1st of this year, 2023. The current amendments, which are very few this time, are in the second round of public comments, and that process is expected to go through and be approved. We do not really expect any further delays at this point, so November 1st does look like a pretty good date for the new code to become effective. We will continue to update our website with the latest information, and you can always ask us if you need an update. So how do we access the codes? One of the best ways to access the energy code is to use the codes IECCsafe.org site, which you can see a screenshot of here on the left side of the screen. That pulls up the code books, as well as a table of contents along the left side. We use this quite often in the office as a way to organize or to get through the code ourselves. That website also has a pretty good search function. If you just hit Control F, you can find words within the code, and it does a pretty good job of doing that. Off to the right side of the page here, we have access to the Illinois amendments, the current proposed Illinois amendments. In order to find those, you need to look up the CDB May 2023 board book and look at those pages there. When the new code is adopted and in effect, the Illinois amendments will be finalized, and we will host a link on our website that allows you to more easily access those amendments. Access to the Chicago Energy Transformation Code. Again, we'll point you to that same website, codes.iccsafe.org. You can look up the new 2022 Chicago Energy Transformation Code there as well. And that will have the same functionality and search features as it does with the base code. And just another point on the Chicago code, almost all of the content, or basically all of the content in today's presentation, applies to the Chicago Energy Transformation Code just as it does to the IECC. So the 2021 IECC arrangement. So we have chapters 1 and 2 that cover administration and definitions. We have chapter 3 that gets into climate zones and general material requirements. Chapter 4 gets into the meat of the energy efficiency requirements. And then where we are today, chapter 5 covers existing building requirements. So we are going to only be in chapter 5 today, with obviously some references back to chapter 4 for certain requirements, but we're going to walk through chapter 5 of the code. Before we do that, though, we have a poll question to answer here before I hand it off to Sean to take us into chapter 5. Get that going here. So first question, how comfortable are you with applying the energy code to existing buildings? I just apply the energy code as if it is a new building. I think I can manage, but regularly have questions about compliance. I'm fairly confident in applying the code to existing buildings, or no problem, bring on the renovation projects. And then the second question there, how much of your work is existing buildings? Less than a quarter to less than half to less than 3/4, or 3/4 or more.
Those responses. We've had a couple people come. I was muted there. We've had a couple of people come in after we made our announcement. Updates on the Illinois 2021 IECC update. At the moment, it's going through the final round of public review comments, and the earliest adoption date should be November 1st, and that date seems to be more certain, but we will update our website if there are any changes to that.
Yes, thank you, John. I'm going to go ahead and end the poll here, share our results. So it looks like we have people who are somewhat confident, but most people, it looks like, need a little bit more confidence in dealing with existing buildings in the code. And then it looks like quite a few of you actually do a lot of existing building work. So hopefully this information today is useful for you. I'm going to go ahead and stop sharing that, and I will hand it over to Sean to take us through the next section.
All right. Well, thank you, Robert. So we're going to start off just with the overview general section for existing buildings in the residential section. So this general requirements section. It's broken down into 6 parts. The scope of applicability for existing buildings with the energy code, how to comply through the IECC, how to maintain buildings and what requirements are contained there, compliance with other codes or older code versions, new and replacement materials when you're working in buildings, how does the code affect those requirements, and historic building requirements. So first, the scope. This section of the energy code for existing buildings addresses additions onto existing buildings, alterations where you're changing out components of buildings for new components. Repairs to buildings have certain requirements. Those are contained in their own section. And then changes in occupancy also have specific requirements. As we're looking at these, additions are generally you're adding to the square foot or the surface area of the building by tacking on additional stories to the building or additional floor space. This kind of overlaps a bit with change of occupancy, where you're changing a space that's already contained within the home, such as an unfinished basement or an unconditioned attic into conditioned space. There's a bit of overlap in those requirements, and we'll go over those. Alterations are where you're taking a component of the building, changing out for a new type of system, but you're not maintaining the pre-existing condition, which is where we get to repairs. Repairs generally are you're repairing the building and putting it back to its pre-existing condition to correct for damage that was done or to maintain the building. So next section, getting into compliance, how to comply with the energy code. Section R501.2 details when existing buildings must comply with Chapter 5 of the code. And so again, here, it's just saying pretty much the same thing as the scope section did. If you're doing an addition, an alteration, a repair, or change of use or occupancy, there are specific requirements you have to comply with. For additions, since you're adding on a new component of the building, it tends to be pretty strict as far as you must meet the energy code as if it's new construction for the most part. There are certain exceptions that we'll get into as we move forward. For alterations, there's a little bit more leeway. There's some acknowledgement in the codes that you're only changing out a portion of the building. You've got to match that to the existing things around you. There's limitations that the existing building puts onto how you can improve that system, whatever you happen to be working on as part of that alteration. And so the requirements as far as meeting the new construction standards and requirements in the energy code are a little bit more relaxed for alterations. So the compliance isn't as stringent there. There's a few more exceptions. For repairs, there's very limited compliance. Mostly it's listing in this section what's considered a repair, and those repairs generally are exempt from full compliance with the energy code. And then when we get back to change of use and occupancy, again, we're going back to you're adding on to a building, so you've got more strict requirements. You have to be closer to full compliance as if it were new construction. Relocation of a building is also mentioned in this section, but there isn't a specific call out in the existing buildings chapter for relocation of a building. So what does that mean for if you happen to be relocating a building? The grand majority of the time, this is to preserve a historic building. You've got to move it to a new site in order to preserve that facility. It's going to fall under historic building protections. But in the certain instances where you aren't moving a building that's designated as historic, you're going to be kind of combining additions and alterations. You've got a new foundation that you're building the building footprint on, you're moving it onto. Technically, that's covered under the addition, so you're going to have full compliance with the energy code for that new foundation. And then the existing building is altered in the movement of that building onto that new foundation. Some alteration things may be triggered in the relocation of that structure. So that's how relocation is kind of handled for existing buildings. Looking at building maintenance, really quick summary here of this section. Buildings need to be maintained in a safe and sanitary condition that complies with the energy code under which they were constructed. So when you're doing repairs and maintenance, that's not going to trigger bringing those systems up to the current energy code. If you're having to swap out a compressor on an AC unit for your home, you don't have to replace your old 12 SEER system with a new 15 SEER or 13 SEER unit as mandated by minimum energy code requirements. You probably will just because it makes sense, but you're not mandated to by the code. If you're just replacing a fan or something like that, the key thing here, though, is that you can't reduce your performance. So if you open up a wall assembly or something, or you're changing insulation, you have to go back in with at least the performance that was there under the code that the building was constructed at. You can't reduce the performance of that assembly. Where we kind of run into this frequently with existing buildings, if you have a masonry wall and it has an interior um, lath and plaster finish on the inside. Some people want to remove that lath and plaster to expose that brick on the inside as an architectural and aesthetic feature to the building. That is degrading the performance of the envelope, though. And so you have to do, if you're going to make that change, you have to make improvements in insulation elsewhere, or somehow add insulation to that wall assembly that compensates for the removal of that lath and plaster. Um, so that's what we're getting into here with maintenance and working on buildings. That's what this section is covering, is that you don't have to improve the performance of the building when you do maintenance, but you can't make it worse than it was when it was than its pre-existing condition. And again, maintenance can go into things such as patching, painting, and resurfacing of walls or other surfaces in the building, replacing components and equipment such as a fan and a condenser or the compressor. Um, if you're not upgrading the entire system, you're just replacing a component, that falls under maintenance. Lighting repairs, or you're changing out the ballast or bulbs in a fixture, but not replacing the entire fixture, that falls under that maintenance and repair section. So again, kind of getting into what's the difference between an alteration and a repair. When do you know which is the condition that you have to go to in the existing building section to find out what your requirements are? Repairs are defined in the energy code as work in a building for the purpose of maintenance or to correct damage. Repairs are largely understood to return the building to its pre-damage state, but not change the repaired area from its original configuration or performance. So the example in the top image here, you put kind of a blocking plate on a wall to patch a hole, and you're going to drywall back over that. You haven't opened up a wall cavity in that case. You don't have to fill that cavity with insulation as if you were altering that wall assembly. Where the bottom picture, you're taking a roof assembly, you're adding more insulation to it, you've changed and altered the condition of that roof. That's going beyond repair, that's going into alterations. Now you're going to have to meet the code compliance requirements for alterations. So it's kind of how we understand the difference between a repair and an alteration in a building, is mainly looking at, are you returning it to its pre-existing condition, or are you altering its performance or characteristics in some way? New and replacement materials. So this section of the code is covering when we're doing work in a building, you changed out some piping or something, you got to replace the insulation, you've swapped out doing some work around windows or something like that, and you got to refinish. You're allowed to go back in a building with like-for-like materials in most cases. The only conditions that are set aside here are when those materials have some hazardous components, such as lead paints or asbestos insulation. Then you could not replace those materials with the same like-for-like material because it presents a hazardous condition in the building. So in those certain instances, then you're allowed to swap out for a similar material that's non-hazardous, but meets the performance characteristics of that previous material. And so this is just saying, when you are replacing new materials, you can't replace hazardous materials with the same hazardous materials. If you're doing work on those, you've got to put in something that's safe for the building occupants and the situation that material is used in. And so we've included some links here that are helpful on asbestos abatement resources and some lead abatement resources, so you have that information handy if your projects involve that kind of work. And the last section to touch on are historic building protections. The Illinois Energy Code has a definition for historic buildings that's very closely matched the IECC definition. Any building or structure that is either listed or certified as eligible for listing on a historic preservation register or by a historic preservation office, designated historic under a local applicable state law or municipal law, or certified as contributing a contributing resource within a national register listed or state designated historic district. So all of these kind of buildings fall under those historic buildings protections if you meet one of these requirements. Buildings or portions of buildings that are designated as historically significant are exempt from the provisions of the Energy Code if that modification required by the Energy Code modifies the form, fabric, or function of the historic building or component and changes that historic nature and degrades the historic preservation that is the goal of the historic building. So when applying for permit, the owner, a registered design professional, a representative of the State Historic Preservation Office, or a representative of the historic authority having jurisdiction for that particular project has to submit a report that designates this is the component of the building that we're altering. This is the code requirement. That requirement has this negative impact on the historic function of the building or historic nature of the building. And that report gets submitted to the code official for approval before moving forward with projects so that we know what components of the building can comply with the codes without significant alteration to the building's characteristics, historic nature, and which components can be exempted from the Energy Code. So something like blowing insulation into a historic building's wall cavities, the Energy Code will still require that for insulation improvement because it's going to be hidden inside the assembly. It's not going to necessarily change the form or nature of that building and impact the historic nature of it. But something like if you're having to repair windows on a building, a lot of historic windows, instead of being replaced, can be revamped or rehabilitated instead of being brought up to code compliance. Because there is a significant difference in some historic glass processing, gives a different appearance to the glazing in those fenestration products. And so there's some protections for windows, just as a couple of examples of what we might see in residential projects. If you're doing an addition on a historic building, the addition does not have the protections of a historic building. Only the historic portion of the building does. So the addition still has to comply fully with the code as if it were a new construction building. Only the historic existing portion has those historic building exemptions. So before we go on to our next section, we have our poll question here. We'll go ahead and launch this poll question. I guess Robert already started it. Yep. So our question is, just as an example, which of the following projects would be exempt from updating to current efficiency requirements of the Energy Code per the existing building's provisions? So if you have an historic building and you're doing an addition on the rear, if you're conditioning a previously unfinished basement, if you're replacing the domestic water heater in a home, or if you're repairing a boiler in a townhome complex. Which one of those would not be exempt?
While we're waiting, sorry. Go ahead. While we're waiting for those answers, do you want to try to tackle the question about fire damage to a building there? So the definition of a repair is the reconstruction or renewal of any part of an existing building for the purpose of its maintenance or to correct damage. Generally, in the case of a fire, the assemblies are being rebuilt to correct damage. So that would be considered a repair in that case. Depending on the extent of the fire, that that if the fire covers potentially more than half of the building, you may have some other requirements there, but you'd have to talk with your local code official. And if you're altering the assemblies that you're putting back, if you're not replacing the fire damaged assemblies with the exact same assembly, you might also potentially trigger something. Do I have that right there, Sean?
Yeah.
Okay.
To the best of my understanding.
Yeah.
And we did have just a quick question in the chat. For this question, which of the following projects would be exempt from updating to the current efficiency requirements? So out of this list, which of these would not have to be brought up to the current energy conservation code requirements?
It looks like everybody's answered, so I'll go ahead and end the poll here.
Mm-hmm.
Share the results.
And it looks like most people got this one correct. Doing a repair to that boiler, you're taking that system and replacing a component on it. That falls under repairs. That boiler does not now have to be brought up to current efficiency requirements of boilers in the energy code. All the rest of those, the addition would have to be built to new construction standards. If you're conditioning an unfinished basement, that has must be brought to insulation, and any HVAC systems installed in that area would have to meet the current energy code. Replacing the domestic water heater, that new heater must meet the efficiency requirements of the existing energy code. So well done on that question.
All right. I will take us through the next section here. So going into section R502, additions. There we go. All right. So to start off with, an addition is an extension or increase in the conditioned space, floor area, number of stories, or height of a building or structure. So one of the key things to pull out there in addition is not only tacking more space onto the outside of a structure, but an addition can also be considered a change in conditioned space, as Sean was just mentioning with his basement examples there. So an addition can be either tacking extra space onto the outside of a building or within the perimeter, tacking more space onto the perimeter of an existing building, or simply creating more conditioned space within the existing perimeter of the structure. Additions to an existing building system, or portion thereof shall conform to the code as it relates to new construction without requiring the unaltered portions of the existing building or building system to comply. So what this section of the code is getting at here is that with an addition, when you add that onto an existing building, the assemblies of that addition will need to meet code as if they were new assemblies because they are new construction. Anything on the existing building that you are not touching or not altering does not need to be brought up to the current code. So if you aren't touching the existing siding or opening the existing wall cavities, you don't need to deal with insulation within those cavities or worry about new exterior insulation or anything like that. You worry about the assemblies on your addition, and then anything that you are not touching within the project scope, you don't need to bring up to current code. The next point down from that, this is something that the energy code points out often, is that energy code requirements should not create unsafe conditions or overload existing building systems. It's the same way with additions. We don't want any additions to any buildings to create unsafe conditions or overload building systems. So we don't want to overload our building structurally or mechanically or create unsafe conditions. That should be pretty self-explanatory there. Additions can comply with the code alone or include the existing building's performance. So what this here is saying, the language for this is contained within chapter 5 there. Lost the section, sorry. Right within 502.1. The addition alone can comply with the new energy code. So just looking just solely at the addition you are making, that can comply with the energy code by itself. That's one option. You can also take the existing building plus the addition and make that structure, the combination of the existing and addition, comply as a single building, as a new single building. Or you can take the existing building plus the addition and demonstrate that it does not use more energy than the existing building. So again, those three options are: you can have an addition that complies with the energy code alone, and you're not considering the existing building at all. You can have a combination of the existing building plus the addition that is complying with the energy code as a new single structure. Or you can have the existing building plus the addition complying with the energy code by demonstrating that you are using less energy than the existing building would have. So those are the three primary options for additions to comply with the energy code. And we'll continue on with that and get a little further into that. The last point there: additions converting unconditioned space to conditioned space need to comply with 502.2. Other additions typically comply with 502.3, and we'll get to those here in a minute. Oops, lost control there. All right. So talking about change in space conditioning again. So any non-conditioned space that is altered to become conditioned space shall be required to be brought into full compliance with the code. This is covered under the addition section of chapter 5. So the key thing there is that if you are why this is important is that you're not necessarily adding on to the structure, but you are adding conditioned space. And conditioned space is where we use more of our energy to condition that space. And so we want to ensure that that space does meet the code, so that we're not just taking, a metal pole barn and adding conditioning and not thinking about the insulation. That's maybe not the best example in this case, but we want to be sure that when we're adding conditioning to a space, that we are thinking about the energy efficiency of that space, so that we're not wasting conditioning energy. So in that instance, that's why the code is caring so much about a change in space conditioning, is because that can have a large effect on energy usage. So examples here: converting an unconditioned garage to conditioned garage or living space. Another example could be converting an attic to a finished attic space. Another example could be the one that Sean brought up previously: converting an unconditioned basement into conditioned living space. All of those would apply under this section. Assemblies that are modified as part of the addition shall comply with section R503, alterations portion of the code, that Sean will cover here in just a little bit. Untouched portions of the existing building are not required to be updated to current code. As I said in the last slide, if you're not touching it, you don't need to bring it up to full compliance. One quick point here about changing space conditions: that first paragraph says that it needs to be brought into full compliance with the code. In this case, that actually means full compliance, even including air leakage testing. If some of you are familiar with additions in the code, there are some exemptions for air leakage testing, which I will get to here in a minute. But if you change the space conditioning, or if you change space conditioning within a space, that space now has to meet the code in full compliance, including air leakage testing. We recognize that this may be somewhat difficult to do depending on the project scope, and that is why the code gives 3 exceptions to this provision that make this a little bit easier to do in terms of how additions are done in reality, or the given realistic project scopes. So the first exception to full compliance, as I just talked about there with the addition of changing space conditioning, is a performance path that is somewhat similar to the performance path for new construction, that requires a proposed design to have less energy cost than a reference design. So this is the first exception to the requirement on the last slide. If you can demonstrate that the addition alone is allowed 110% of the annual energy cost determined by section R405.2. So basically what you're saying here is that the addition can have 110% of the annual energy cost, and that accounts for a little bit of that. It gives you a 10% buffer there for connecting the addition to the existing building. We know that existing buildings can be in all sorts of different conditions. Maybe you're putting on a very high performance addition onto the building, but the existing building is not necessarily high performance. This is giving you a 10% buffer there to make up that difference. So this is the first exception to full compliance for an addition that is changing space conditioning. We'll go to the second exception here. So again, this is similar to the performance path for new construction. The process, the approach with modeling is similar. The target is what's slightly different here. So for new construction, prescriptive compliance can be obtained if the proposed building insulation and area factor, so the UA of the building, is less than or equal to prescriptive values. So for new construction, you're comparing the UA of your structure to the UA that is calculated with the U value tables within the prescriptive requirements of the code. So you're comparing the UA of your building to the UA of the prescriptive requirements of the code. This exception number 2 under additions states if the addition plus the existing building's total UA per R 402.1.5 is less than the existing building total UA before the addition is compliant as the overall building performance is improved. So again, it's kind of that same idea. We can't make anything worse. We need to improve things. So in this case, you're taking a look at the total UA of the addition plus the existing building. So think of our blue little building there. You're adding up the UA both of the existing and the addition. That UA must be less than the UA of the existing structure before the addition. Most likely, this would require some fairly significant retrofits to a building if the addition is large. If the addition is a pretty big addition, you probably are going to have to be doing more insulation work and other efficiency improvements in other places around the envelope. If this is a fairly small addition, so like potentially a small bump out in a kitchen, you might be able to insulate those walls to a level such that this exception applies fairly easily to that project if it's a fairly small in scope project. So that's why this exception is there. Depending on the scope of the project, this may or may not apply easily. But again, it's taking the UA of the addition plus the existing. That UA needs to be less than the UA of the existing before the addition was included. And then, whoops. And our last exception here to full compliance for spaces that have space conditioning changed. When using the performance path, if the addition plus the existing building energy cost budget is less than the existing building before the addition is compliant as overall building performance is improved. So again, this one is very similar to the last one on UA trade-offs. Instead of looking at the UA of the building and the addition, you're looking at the energy cost of the existing building and the addition. But the target here is the same, is that we want the energy cost for the existing building plus the addition to be less than the energy cost for the existing building without the addition. So again, we're trying to show improvement here. This is what we want. We don't want any of our buildings to perform worse after we perform a new project or addition on them. We want them to perform better. Oops. All right. Moving on here, section R502. So additions. So additions considered alone must meet the prescriptive requirements for building envelope performance, heating and cooling systems, service water systems, and lighting. So this section here, we're talking about additions that are not necessarily changes in space conditioning, but other additions, actually adding space onto the exterior of a building. So these type of additions need to comply with these prescriptive requirements as they would for any other new construction. So for building envelope performance, the additions in this case are exempt from air leakage testing, but must still perform air sealing work detailed in R 402.4.1. The reason that these additions are exempt from air leakage testing is that, again, we don't necessarily know the condition of the existing building. The existing building could be in good shape. It also could not be in very good shape. It could be incredibly leaky. And depending on how leaky that existing building is, it may just be near impossible to pass an air leakage test, even if you build your addition as well as you possibly can. So in that case, taking that into consideration, the code exempts additions from air leakage testing. But now these are additions that don't involve a change in space conditioning. Again, that's a different case. If you're changing space conditioning, that goes back into the requirements that we just covered, where you need to fully comply with the code unless you fit into one of those 3 exceptions. So talking about additions that are not changing space conditioning, we must meet building envelope performance. Heating and cooling systems, ducts that are extended from an existing system are exempt. So if you are extending an existing system, those ducts do not need to meet the requirements of the new code. If you are putting in a new system and a new duct system, so So a new air handler with new connected ducts that aren't connected to an old system, those would need to meet the requirements for a new system as they would with new construction. Must ensure the existing system is not overloaded by serving the addition. So if we are extending ducts from an existing system into a new addition, we want to make sure that that extension isn't overtaxing that existing system. We want to make sure that that existing system still functions properly, even if we are extending it into an addition. So we can't, again, that's in some ways that's going towards the not making an unsafe condition or overloading existing building systems, right? We want to make sure that our addition is not doing that. For service hot water systems, new systems must comply. Extensions of existing systems must be insulated according to code. So a little bit different there than the ducts. If you're extending an existing system, you do need to insulate those pipes. Lighting must comply with all the requirements as it would as if it was new construction. Building envelope. So looking a little bit more specifically at the building envelope, new building envelope assemblies that are part of the addition shall comply with the following sections: thermal envelope requirements and exceptions for low energy buildings, unconditioned spaces, and log homes. So if the project is low energy, unconditioned, or a log home, it would be exempt from the thermal envelope requirements, just as it would if it was new construction. Getting into section R402.2, prescriptive requirements for specific assemblies, so walls, foundations, roofs, and floors. Those assemblies need to meet those requirements as if they were new construction. R402.3.1 through 402.3.5, fenestration requirements. Again, the fenestration needs to meet the same requirements as if it was new construction. And then air sealing requirements, R402.4. So we do still need to meet air sealing requirements, but these additions, as I said earlier, are exempt from air leakage testing per R502.3.1. And again, that depends on if you're changing space conditioning or if you're just adding on to the building. All right, special chapter 4 applications. So this here, R402.2 opaque assemblies. We're calling this out here as kind of an easy way to lessen the amount of insulation you need to include with your project. So R402.2.1 allows R38 instead of R49 or R49 instead of R60 roof insulation if 100% of that of the ceiling or attic area is uncompressed and full depth insulation extends over the wall top plate. So the easy way to achieve this is to make sure that you're using raised heel trusses as shown there in the bottom image, so that we can make sure that that roof and attic insulation is uncompressed all the way to the exterior wall, so that we don't have any sort of thermal weak point there at that upper corner. That's what we're trying to avoid here within the code. So you get a little bit of a reduction in insulation requirements if you make sure that that upper corner is uncompressed. Clarifying chapter 4 compliance continued here. So looking a little bit more at fenestration, section R402.3, the area weighted U factor can be used to determine, or in compliance for fenestration here, you use the area weighted U factor. For buildings that are greater than 50% glazed, you use the area weighted solar heat gain coefficient. If the addition is a sunroom or heated garage that remains thermally isolated from the house, reduced insulation values can be used for compliance. Those reduced values are shown there below. So R19 or R24 for ceilings and R13 for walls. Pay attention to the note there at the bottom of the slide. Reduced insulation does not apply to detached heated and cooled garages, because if it is heated and cooled, then that is conditioned space and it would need to comply with further requirements in the code. Section R402. So again, covering the air sealing, we need to make sure that the envelope must be air sealed per the section. Seal around air barrier penetrations, seal seams between materials and assembly joints, seal around windows. Need to make sure that all of those typical air sealing details are achieved. But again, the building additions are exempt from air leakage testing. Heating and cooling systems, as I discussed quickly earlier, HVAC ducts newly installed as part of an addition shall comply with section R403. If you're extending those ducts, they do not need to meet the requirements of section R403. If they are new, if it's a new system and a new duct system, it does need to meet those requirements. So the key distinction there is if you are extending the existing system. Any other mechanical components of addition must meet applicable R403 requirements, even though not specified in R502.4. So system sizing, efficiency, ventilation, all of that stuff needs to be complied with as if it were new construction. Surface hot water systems. So new surface hot water systems, if circulation is employed in them, they must have demand-based flow controls. If heat trace is used to maintain hot water temperatures, they must meet UL 515 or IEEE 515.1. Pipes must be insulated to at least R3. Lighting, new lighting systems that are part of the addition shall comply with section R404.1. All permanent interior and exterior luminaries, fixtures must be at least 45 lumens per watt, and lamps must be at least 65 lumens per watt or better in efficiency. Permanent exterior lighting shall have dimmable and daylight responsive controls per C405.4. And then there is an exception to that requirement for daylight responsive controls for single family and townhouse homes and lighting that is solar powered or controlled by motion sensors. Okay, so at this point, I'm going to start our next poll question here before we move on to the next section. So this poll question is: a contractor is working on a 720 square foot detached garage conversion to a heated and cooled space using a 1.25 ton heat pump. So that's 20.8 BTUs per square foot. Select all of the following that apply to this project. Insulation is exempt as space is a low energy building. Air leakage testing is exempt as this is an existing building conversion. Ducts for the HVAC system do not need to be insulated or tested for air sealing. A performance model of the garage can perform 10% worse than the garage model to meet the current energy code.
While our poll is going, we've had a couple of questions come into our Q&A. One, for additions, does the new standards apply only to additions or also to the portion of the building connected or renovated adjacent to the new addition? So the addition itself must comply with new construction standards. The connecting portions of the building, like if you're doing a sunroom addition on a house, the wall between the sunroom and the existing house, if you alter that wall, it must comply with the alterations portion, which we'll touch on next. So may require full compliance, may not, depending on the type of alteration. We'll touch on that.
Like we still got a couple answers trickling in here, but I'm going to go ahead and end the poll. Looks like the majority of everybody's getting this right here. The correct answers are number 2 and number 4. So number 1, insulation. This is not a low energy building. 20.8 BTUs per square foot is pretty far above the 1 watt per square foot threshold there for a low energy building. Air leakage testing is exempt as this is an existing building conversion. That is true in this case. Ducts for the HVAC system do not need to be insulated or tested for air sealing. That would be required no matter what, whether you were extending existing duct system or not. And then lastly, the second correct answer there, performance model of the garage can perform 10% worse than the garage model to meet the current energy code. Okay, at this point, I'll pass it off to Sean to finish this up here.
All right, thank you. So going into alterations, any construction, retrofit, or renovation to an existing structure other than a repair or addition must also a change in building, electrical, gas, mechanical, or plumbing system that involves an extension, addition, or change to the arrangement, type, or purpose of the original installation. So if you have a system, you do some work on it, and it doesn't look exactly like the previous system, you've altered it. So that is an alteration. Alterations shall be such that only the manipulated parts of the building need to be brought into compliance with the code. Again, things that you aren't altering and aren't touching as part of the alteration don't need to be brought into compliance. We're only the existing building code only requires you to bring into compliance things that are changed as part of that alteration. Envelope alterations need to comply with all sections of the prescriptive insulation requirements in section R402, except for air leakage testing. Again, we've covered that exception. Specific requirements that refer to the entire building are excluded from compliance here as well, since alterations only impact portions of the building typically. If you're doing a whole home renovation where you're touching on everything, you're pretty much going for a new construction compliance anyway. There are some exceptions to full compliance for alterations that we want to touch on now. Um, they're listed in this section for alterations. If you're installing storm windows over existing fenestration, that's an alteration to the window, but the storm window doesn't have to have the U factor and solar heat gain to meet full energy code compliance. Um, Storm windows are an inexpensive add-on to a building. They're not going to have that performance themselves. They are improving the performance of the window, so it's allowed by code. Um, Existing ceiling, wall, or floor cavities that are exposed during construction do not have to meet full insulation compliance, provided they are filled with insulation. So this is where we kind of touch on going back to additions. That connecting wall to your addition, if you're opening up a cavity in that wall and you expose a cavity that isn't completely filled with insulation, all you have to do to comply is fill that cavity with insulation and you're in compliance. If it's a mass wall, there's no cavity there for you to expose. And so as long as you're not degrading the performance of that by removing insulation from that wall assembly, you don't have to do anything to improve a mass wall assembly if an addition is connecting to it. Construction where the existing roof, wall, or floor cavity is not exposed. So again, touching back on a mass wall assembly, or say you've got a roof with attic floor insulation, and you're working on the roof deck. Since the insulation and everything beneath that isn't going to be touched by replacing the roof deck above that insulation, you're not required to add more insulation into the attic space when you replace that roof deck. Now, if you have a cathedral ceiling and you remove the roof deck, you've exposed a cavity. So now you just have to make sure that cavity is filled. That's how kind of those roofing things can interact with those exceptions. A roof recover where you're adding a new covering over an existing roof covering. So adding shingles onto an existing roof. If you've got a low slope roof with a membrane, you put a new membrane on top of that without pulling up the existing membrane. You don't have to improve the performance of that roofing assembly as far as insulation. Roofs without cavity insulation and with sheathing or insulation exposed during the alteration shall have insulation added either above or below the sheathing. Surface applied window films don't require those windows to now meet full energy code compliance. Again, it's an improvement to the window, but you're not expecting that window film to increase the U factor of that window at all. It's reducing sunlight and glare coming through. You might get some improvement to your solar heat gain coefficient. For roofing without cavity insulation that has sheathing or insulation exposed during your roofing, insulation shall be added above or below the sheathing. Looks like that made it on there twice somehow. For HVAC system, ducts that are newly installed as part of an alteration must comply with section R403. So again, if you have a new HVAC system with new ducts installed into a building, those must comply fully with the energy code as far as insulation, air sealing of the ductwork, and testing that ductwork for air leakage. So if you do like a full rehab of the building, you remove all the existing ductwork and you're putting in a new system, that's when you have to meet this full compliance. Again, the exception is listed here if you're extending ductwork for the purpose of serving an addition, those ducts are exempt from those requirements. For service hot water systems, new systems must comply with the energy code. That includes all the subsections for service water heating that include pipe insulation and circulation system controls if you're installing them. Unlike commercial buildings, residential buildings don't have the language in the new construction that pretty much mandates hot water circulation due to the maximum volume limitations or pipe length limitations to a heat source. Residential doesn't have that requirement. So if you have circulation system controls installed, they must comply with the circulation system controls requirements. If you don't install a circulation system, you don't have to worry about it. And then all the hot water piping must be insulated as required by the code. For lighting systems, alterations where you're replacing permanent lighting fixtures with new permanent lighting fixtures, those must be high efficacy lighting fixtures as was defined by Robert earlier. Alterations in a building that are replacing less than 10% of the luminaries in a space do not have to comply with that provision, provided those alterations do not increase the installed lighting power. This can be a little bit difficult to hit this exception in residential because there's so few lighting fixtures in each space. Usually you've got one main luminary in each room. And so if you start swapping out a space, you're going to hit that 10% pretty quickly. This brings us to our next poll question. I'll go ahead and launch that. A contractor is replacing a low slope condo roof with new decking and membrane. The insulation is below the roof deck in the framing cavities. What does he have to do to comply with the energy code? Does he have to install above deck insulation that gets him to that continuous U factor of 0.024, about an R41.7 for that assembly? Does he have to ensure those cavities are filled with blown-in insulation or other insulation that fills that cavity? Does he have to fill the cavities and then fur out on the interior to ensure he's got that full R60 to meet the new construction requirement? Or does he just replace the decking and membrane and not do anything with the insulation? And we've got a couple more Q&As to answer here while we're getting some responses into that poll question. Someone wanted us to explain the exceptions for full compliance for additions again. The first exception is if you're modeling the addition alone, you've got a 10% buffer over the performance requirement. So your performance model can perform 10% worse than the reference model to account for connection to the existing building. So that's the first exception. The second exception is when you look at your addition plus the existing building's total insulation area factor, the UA factor, that has to be less than the existing building's UA alone. And so that will require some work in the existing building to improve the insulation there, or would apply to very small projects where the small addition to the building improves the overall performance of the existing building enough that complies. And then the last one was if you model the existing building and the addition together and their energy cost is less than the existing building alone before the addition, that is also in compliance. Looks like our poll question is done here. This one was a little more confusing, looks like. Let's share those results. So the correct answer here was, since this is roof insulation that's in a cavity, all you have to do when you expose that cavity is fill the cavity with insulation. So answer number 2 here was the correct answer. The others don't apply in this particular situation because it's cavity insulation in the roof, like a cathedral ceiling, let's say. If this had been insulation above the decking and that was exposed, then you would trigger increasing that insulation as much as you can, given some other existing constraints on the roof. And so you would have to meet that either that U factor for new construction or that R60, depending whether you're doing the U factor compliance or the R value compliance. So those are the correct answers if that insulation had been above the deck. But since it was in the cavities, number 2 is the correct answer to that poll question. And we've got a last short section here, and then we'll get back to some of the Q&As and wrap those up. But we want to touch on the last couple of sections here. They're fairly short for existing buildings. First is repairs. This section of the code defines repair, which we touched on earlier, the reconstruction or renewal of any part of the existing building for the purpose of its maintenance or to correct damage. And then it calls out specific things that may be considered alterations as repairs so that they're not confused. So if you're doing a glass only replacement in an existing sash and frame, so you're renewing a window with some new glass in the existing framing material, that is a repair to that window. But say a ball or a rock went through the window and broke it, you had to replace the glass, but kept the window framing and sash. That's a repair. Roof repairs, such as after hail damage, things like that, those fall into repairs. And then lighting, where you're swapping out the bulb or the ballast. As long as you're not swapping out the entire fixture, that's a repair when you're swapping out just the bulb, the ballast, or both, as long as you're not increasing the power consumption of that lighting fixture. And then back to change of use or occupancy. This section is going to refer you back to the R502 section for additions. Any space converted to a dwelling unit or portion thereof from another use or occupancy shall comply fully with the code. So if you're converting a garage that was unconditioned space into a dwelling space, such as a bonus room on the house or an additional living space, converting the unconditioned basement. If you're converting residential space to commercial space, say you've got a multi-tenant building and you're turning the first floor into commercial shops, then you're going to have to go to the existing buildings for commercial buildings and look at requirements there. In general, spaces that undergo a change in occupancy that increases demand for fossil fuel or electricity shall be brought up to code. So again, this is looking at if you're adding on to a building through changing unconditioned space into conditioned space, that's going to increase your demand for fuels or fossil fuels. That's going to trigger you to bring the building into compliance. So any unconditioned space that is altered, again, goes back to the R502 section, and it's restated here. When you're using the simulated performance path option for an existing building where you've converted unconditioned space to conditioned space, you've got that 10% buffer when you're using a building model. So the existing building gets modeled to the energy code new construction standards, and then you do your performance model, which is what you're actually building. That's got that 10% buffer. It can do 10% worse than that reference design and be in compliance with the code still. So there's that little bit of exception, gives you some wiggle room. So what we wanted to here is our last poll question, and then we'll get to some of the Q&As here as well. The work shown on screen, is this repair or alteration work? We've had some discussion in the chat addressing one of the Q&As about if you're removing lath and plaster, how do you best insulate without introducing too much moisture, preventing mold growth and things in a cavity. And there's been a lot of discussion in the chat with Ryan and stuff. Hopefully that has addressed that question. If you need more follow-up, please shoot us an email and we'll be happy to follow up in more detail. Oh, Ryan only sent that to us. Let me
try to catch up on that here.
Yeah, if you can find that in the chat and address that question, that would be great. Looking at our poll question, we'll go ahead and share those results. Looks like everyone got this correct. This would be a repair. We're going to return this wall back to its pre-existing condition. We're not going to alter that wall in any way. Just going to reinstall that brick, plug that hole, replace the framing and things back where they should be, insulate that back to the insulation level it had before. That is a repair. So while we're going through our Q&A questions here, I'll throw this up. So if you do have a detailed question, we'll refer you to this email address. Send us an email and we'll get a detailed answer to you. For the attic floor insulation, is there language addressing blanket insulation, which may not close above stringers or trusses, and blown in, which would cover the wood? This is kind of part of why attic insulation, when you're following the prescriptive tables, has the R60 requirement, is it's accounting for, you've got these wood penetrations, a little bit of discontinuity, and so it's added some additional insulation requirement there. When you look at the U factor table, It's a slightly less, a lower R value. I think it's a R41, 42-ish. And that accounts for the overall performance of the assembly. So the installed insulation would still have to be about an R60 to achieve that R41, 42 performance level because of the penetrations for wood framing coming through that insulation. The code doesn't address the type of insulation differently. Where there is a difference is when you can get full uncompressed insulation coverage across the attic out over the top plates, using that raised heel truss as we showed in our example. That's where you can reduce that prescriptive R value from the R60 to the R47, or from the R40 to the R30, the R45 to R38. Because you're getting full insulation coverage out over the top plates of the walls where there's typically a bit of a thermal break there. But no, there isn't any kind of language that differentiates between the type of insulation installed in attic floors. So we had a poll question earlier. It was a garage that had a new system that was heated and cooled. That new HVAC system is not exempt from duct testing requirements because it's a whole new system in that garage. So a little bit of a clarifying question there in the Q&A for that poll question in the additions section of this presentation. So it was a heated and cooled garage. It's exempt from the air leakage testing requirements. It has HVAC system installed that does not allow it to qualify as a low energy building. So it's using too much energy in BTUs per square foot to qualify for that. So it has to meet the full insulation requirements. Since it's a new HVAC system and not an extension of the existing duct system, the ducts system has to fully comply with the insulation requirements. I can't remember what the last option of that list was at this point.
That was the performance model of the garage.
Oh, yeah.
Garage can perform 10% worse.
Yeah. So when you model that garage, allowing for it being an existing building, you can have 10% worse performance with a performance model over the reference design for that building.
Yeah, thanks for clearing that up. I may have misspoke on that one earlier. I'm looking at the Q&A we got about the lighting. I think the key to your lighting question there is if that one fixture in the space is being replaced as a repair or as an alteration. If that lighting fixture is just simply being replaced as it's not functioning, that would be a repair, and then you would not need to bring the rest of the lighting in the classroom up to the current energy code. If you are actually altering that fixture and changing the output, changing the fixture type, then that could kick in having to alter the rest of the lighting in the room. If I'm understanding the question correctly there. And we got a couple questions on the exception number 3 to the change in space conditioning. So the code language states that that is on an energy cost basis.
Right. It's not cost per square foot. It's cost basis.
Yes.
Total cost.
Yeah.
So going back to the lath and plaster over a masonry wall, how to best insulate without introducing too much moisture. One of the ways we've seen that done is continuous insulation on that wall on top of some furring strips that isolates that wall from any kind of moisture sensitive materials. We've also seen a 2x4 wall in front of that with R15 insulation in it that meets the U factor compliance requirements for an exterior wall assembly. That bit of airspace between the framing and the masonry wall prevents direct contact where you could have condensation then leach into the wood and cause moisture issues. So those are kind of the couple of ways we've seen those handled as assemblies and preventing moisture issues in those masonry assemblies.
Mm-hmm.
once you've removed a lath and plaster assembly.
Yeah, another point there is just to keep in mind where your vapor barriers are within the assembly, between the existing materials and any new materials you plan to add. Just pay careful attention to vapor permeance of those materials to make sure you're not trapping moisture. But um, how, how much insulation is required for this skylight?
Oh, so the walls around a skylight. If you add a skylight into a building, those vertical assemblies that are part of the skylight would have to meet new wall R value requirements. So the R20, if you're using cavity only, or if you're using a mix of cavity and continuous insulation, it would have to meet those new construction compliance tables.
Right, but it is treated as a wall. Yes.
Yep.
Yeah. Yeah.
We had something in the chat, just clarifying our alteration to the low slope roof question. They wanted to make sure on a low slope re-roof project, replacing just the membrane, not the rigid insulation, you would have to evaluate and possibly increase the insulation. So yes, if you pull the membrane off the roof and you expose the insulation or roof deck underneath, you would have to, for insulation above deck, increase that insulation level. There are possibly some limitations that would limit how much insulation you can add to that roof. And so you would add as much as you can given those existing limitations. But yes, if you expose above deck insulation on a low slope roof by pulling up that membrane, you would have to increase the insulation performance. In our particular example, it was a low slope roof with cavity insulation. So all the insulation was under the deck. In that case, if you pull the deck up and you expose the cavity just has to be filled. Another question came into the Q&A, a low slope re-roof, where work resulted in reducing or eliminating ventilation openings and where membrane became the air and moisture barrier and cavities were filled with insulation may cause condensation on the bottom of the roof deck. Does the code accommodate building performance issues like this? So if you have a filled cavity, it should not be ventilated. There are particular cases where you have a cathedral ceiling, and you can have a fully enclosed cathedral cavity assembly, or you could have a ventilated cavity assembly. And that's where attic baffles come into place. For the fully enclosed assembly, there is no ventilation under that roof deck. It's essentially treated like an angled wall assembly. It's fully enclosed, fully airtight. The insulation can be in contact with the roof deck. The inside of that needs to also be airtight. So if you're planning on putting can lights or something in there, they need to have the airtight insulation close can fittings to minimize any air infiltration from inside the home into that cavity that might cause condensation issues. For a ventilated vaulted ceiling assembly, the insulation is installed underneath an attic baffle that provides ventilation along that roof deck, provides that 2-inch air gap for that ventilation. And so in that case, you fill the cavity underneath the baffle. The baffle provides that ventilation gap between the roof deck and the insulation. So those are the two different ways to do those assemblies. But for a low slope project, that should not be a ventilated assembly. It should be an airtight enclosure where you're not going to get extraneous moisture into those cavities that could then condense.
We got a question about insulation on the interior of mass walls affecting the UL rating. That is certainly possible. I know that there's quite a library of UL rated assemblies out there, and you may just have to do some searching to see if there's another one that applies. We do not necessarily have a library of those that are code compliant available to share.
And I know we've gone over time. We're just answering QAs right now.
Yeah.
If you have to leave, the presentation is over. If you
Yeah.
have specific questions, please do email those to us, and we'll address those as they come in. So at this point, I think we will, the last few questions here, if we haven't addressed them, again, send us in an email. We'll address those for you. Thank you all for attending today, and we hope this has been an informative session for you.